Hello, everyone. Hello, everyone. Welcome to this class. Okay. This class is really an important class. I think you see threads all out in everything that you do is threads. You just signed up into this Canvas application, and every time someone is logging in, the thread is going on. The thread gets created for you. The thread gets created with me for me. The thread is getting created for everyone. And so what you have is you have a computer. You have a computer that you have a laptop. Basically, it's got 3 layers. Okay, there are 3 layers. One is what you see. Every day you use so many different applications. And then there is another layer, which is the hardware side, which does the processing. Okay, and what you do, if you write your own code, you write it in some type of high-level language. Okay, Java, C, C++, Python, these are high-level language. The machine itself is only knowing is the 0 and 1. There are 2 alphabets for machine language, 0 and 1. Different sequences of this 0 and 1 means different things. In English, we are using, 26 characters in English. So you you use those characters and you put them in different sequence. They mean different things. But for machine, it's only two letters, 0 and 1. Different sequence means different things. Okay, 0 1 1 1, 1 0 0 1, 0 0 0 1, 1 1 1 1 1. Okay, so there is only you have the base and then you have the machine, and then what is going to go? Something else has to happen between what you write and what the machine gets executed. It is the machine, it is your CPU that executing the instructions. And what's in the middle is the operating system. It is the operating system that does the management of all this. It's not the topic of this class. It belongs to another class, but the importance is there. So we want to run things. We want to make things efficient. We want to run things. We want to be able to manage more applications at the same time. We want to use memory more efficiently, so we can service more requests. A request can come from different programs. These could be your program, or you running, say, for example, calculator that's open, and then you open, a calendar, you open your own game. So all of these are different programs, and there are programs, and then there are programs that you don't see. They are behind the scenes. They just created for various reasons. For example, operating system itself is doing all this, programs behind the scenes to manage the services. But each one of those things, whether it's the user level or the system layer, when they got executed, they run, the operating system is going to treat all of them the same, whether it's your program, the other program. So you have said one program is you and my program A is of A, B, C, and then C is system program. Okay, they get started. What needs to happen, you get loaded into memory, right? You have to allocate memory for those, when you start your program. You load it into memory. And then...
I'm sorry, Professor.
This is where...
I cannot see your screen.
Are going to get more detail. I'm not going to get there because it belongs to another class. But I want you to know the top layer. Every time you start a program, that program gets loaded into memory. There are different ways of doing memory management, okay? But generally, you load the program instructions into memory, right? You allocate memory for that. And then you set the location address in memory, and that will basically put it on the address bus and
excuse me, Professor.
Asking CPU to just execute that instruction at that. It takes the one instruction and then finish that, depending what the instruction is, whether it's stored somewhere else or there may be dependencies. So it's going to go to the next instructions. And remember, memory is just addresses, right? What is memory? It's just a storage. Every storage in the world has two things, an address and what goes inside that address, called value. You know, your home has an address. Your home has an address. And then what goes in there are different rooms, and then each room has furniture, that's data. So each one, you have 3 rooms, you have room 1, 2, 3. So you've got an address 1, 2, 3. And then what is inside that location room is your furniture, your TV, and so on. Okay? So every storage in the world has got 2 properties, address and what the value that goes into that address. Okay. So we are saying this because we want to use our machine efficiently. Okay. Now, you run multiple programs, then you have multiple processors. A program in memory becomes a process, and that process has a PID. You know, if you're using any operating system on the command line, you can ask what the process ID of a specific program is. So you can look it up. So every program, if you load in 3 programs, you have 3 processes running. And each process has a process ID. And then you allocate, operating system is going to basically give you a slice time to your program. Then whether you finish your program in that time slice, or it's going to switch to another. Okay? It's going to switch to another process. Gives a slice time to the second program, and then if you finish, whether finish, you exit. If you're not, it's going to go to the next one. So it's going to do one sort of algorithm is called round robin. It gives time to you, and then gives time to me. It gives time because it wants to provide more services. Okay, so we want to do this efficiency. There is a memory management efficiency. There is a scheduling of programs efficiency. So those are some of the basic general things about the operating system. But what we want to do, we want to extend this efficiency to other areas. That other areas is that you write a program, right? What program is that you define what the program does. It takes the task and does certain steps on that, a logical order, and then you get to your results. And then you do whatever you want to do with the results. That's it. So if the program is large, okay, depending on task, for example, Northeastern Canvas or Blackboard, these are very large. There's at least 20,000, 25,000.
Hello, Professor. We can't see your screen.
But it's pretty large every time you create. So what we did over time is that you over time we learned from the
Hello,
technology
Professor.
expanded, and we cannot be single threaded. Like you finish one to the end and then go to the next one. Start from in? No. It's just not, it's not going to happen because the inputs, the requests are larger than the processing time.
Hello, Professor.
So what we want to do, we want to make this efficient.
I guess
So
he's not able to
what do
hear
we do
us.
efficiency?
Yeah.
How do we do efficiency?
Hello, Professor. Are you there?
The task is
Can you
that
guys
so
raise
a
your hands?
student gets into a system, it does
Is there
have
recording?
functions. It looks at the grade.
No, I
it
don't
looks
think
at
it's a
its
recording. Maybe
listing,
you can raise
registers,
your
it
hands
looks
if
at,
he'll notice that.
all kinds of things that you can do. So what we want to do, we want to take this large task and break it down into small pieces. Okay? Now, when you break it down into these small pieces, so the idea is that you want to run you took the big task and you broke it down into a smaller task. So for example, you took a big task and you analyzed the task, and you said that I can make this 20 tasks, subtasks. And then you say, now, okay, so that's the design thing. You analyzed it, and then you created threads. You created the task, and then now you say, okay, I want to use 20 threads. Each task becomes a thread. So I want to use 20 threads. Okay? So now, so you run the task. So what is the task? How do you identify a task? You looked at the whole application, and you logged into Canvas, and you do various operations in that. You do the A, you B, and then you go A again, you do C, you do all these features that are available to you. Okay? So we identify the task, and then you identify the task, and then you say, okay, I want to make this large application to be 20 tasks, 20 subtasks. And each task I want to support a thread, identified by a thread. Now, what happens is that now there is two to it. Either the task that you start, so now you're creating threads, 20 threads, and you're making each thread to run on task 1, thread 2, task 2, thread 3, task 3, ... to thread 20, task 20. Okay? Now, the task has a start and the end, right? Now, if you identify the task, the task, you identify the task that 15 of them are, you can start and complete and just go to finish. So you start and you can end. So 15 out of, let's say 10 out of 20 tasks, now is 10 threads, are tasks that you can start and it goes, it doesn't stop until it gets to finish. Okay? But the other 10 threads, the other task is that the threads are running, they're starting a task and do. But then the threads are not able to complete the task because there is a resource. The resources that are available, they need each other. You have a set of resources. So say, for example, we already decided that the first 10 is that there are tasks that you can start and finish. It stops until it finishes. There is nothing interruption. But the other 10 are tasks or not are threads that they cannot start and finish. They need system resources. Okay? These are resources, it's called shared resources. These are resources that you either create, for example, your own shared resource, a hash map, or a queue, or something. Or there are system resources, like accessing to the files, accessing to connections, you know, you know. So you cannot finish to the end. So what needs to happen is that you need inside, remember, you took the big task and you divided into 20 tasks. The first 10, you can start and end. The second set, there is dependency. What dependency means that shared resources are required. So thread 11 starts and then needs shared resource A. Okay? And so it comes in and how do you know inside your program? The task is a program. You have the big task, and the thread is a subtask, which is a program now, right? It's by itself. It's a thread. But that thread is your program saying that you're referencing, for example, to open up a file. But the system comes back and puts a block on it because maybe the maximum number of access to the file is maximized, so it cannot do until one releases. One of the threads that is reusing the file has to close, and then that opens up one, and then you access. I'm giving you a general example. Different scenarios happen when you're talking about shared resources.
Hello, Professor. We are not.
But this is the thing.
Your screen.
What I'm getting at, the basic thing is that two topics: parallelism and concurrency. When you create a task, a subtask, a thread, you can you can start that task can start and finish without any interruption. Then you can do this. So we are talking about, in this case, we have 10 threads, which was 10 subtasks, and these 10 can start and finish on the CPU. The speed and whether you need one CPU, or depending on the speed of each CPU, and so on. So as long as you have CPU, is basically the task does not has any interruptions. It can start and execute and finish. Okay, but the other side, the other 10, as I mentioned, is concurrency. Concurrency means that the thread, the subtask 11, 12, 13, 14, up to 20, these tasks need resources, and we don't have enough resources to basically give multiple things to each thread. So we have to manage this. Now, the simplest version of that is that so you have to give access to resources, and you cannot give everybody access because it's just limited resources. So what you need to do, you need to basically obey the rules of concurrency. And concurrency means that you come in, let's make this resource to be an apple pie. You come in, okay, then you have 10 threads, they need apple pie. They want to get a piece of apple pie. You cannot have 10 hands. So thread, I'm not going to say the subtask anymore. I'm just going to say thread, because we broke down the big task into subtasks, and now each one of subtasks is a thread. Now you have 10 threads, and they come execute the instructions of the program. Step 1, step 2, step 3. But the step 4 says, oh, I need apple pie. Okay, so it cannot. Step 4 says apple pie. It cannot go to step 5, execute a step 5, because it needs to get a piece of apple pie before it can continue with the step 5. And then, so what I'm saying is that the subtask that you identified as a thread, it has a dependency, and that dependency has to be defined. For example, another simple example. Have you seen that, you open up a file and you want to read? Okay, so you read it from a standard input. You start your program, and then program stops. It doesn't continue until you put something as an input in there, and then it does the validation of your input. If it's correct, it continues. The concurrency works like this. Yeah, no, not to worry.
Hello, Professor.
Hello, everyone. I don't know what happened in terms of connection.
Hello, Professor. Can you hear me?
Thank you. Yes. God. I don't know. I was talking to, on topics. I'm not showing any screen right now. I just hope that you followed what I was saying. In terms of a screen, not to worry, because I was not targeting any screen at this point. Okay?
Okay.
But did you hear everything I was saying?
Yeah, we can hear you.
Very good. Because then I went to the screen, it was gone. I wasn't sure what happened. We are in a new canvas, and I'm new with Zoom, so this is, I don't know what happened really. So I'm glad at least you heard me, because I was not targeting any screen. I was just talking about, a generalization of topics. So, okay. So I don't know if this is missing a student. Okay, folks, let me continue. And I need to now be careful about this because I don't want to lose you here. So I was basically on the topic of what we are talking about, why we are here. We are talking about parallelism, concurrency, multi-threading. That's why this course is really important, because you may have other classes but not focus on multi-threading or on concurrency. But it could be a hard topic, because if you have object-oriented programming, they talk about how to create threads. You can do, inheritance by thread library, or you can do it inheritance by through interfaces runnable. And then you probably did that, and then you wrote some applications. But generally, you have to understand more about this, because you cannot see threads. You cannot see how the behavior of the threads. Okay? And I started with the topic of, basically trying to say, so how are we going to build a thread application, multi-threaded application? You took a task, You analyze it, and you say, you basically build a subtask, you know, and they say this task can be broken down into 20 types of tasks. Okay, so that's how we do it. I'm hoping that you followed me. If it looks like you were hearing me, that's good. Okay, but I don't know why I lost the Zoom. I don't know. Any case, because I needed to show you things, right, you know, and different slides and things, and I'm hope that I don't lose you, you know. So I'm going to check more often now to see if everything is working, you know. But everything is online, and coronavirus. I just need to be careful and try to do this online. Okay, so that's so that's enough. If you heard me, I think that's really great. I'm really happy because I don't have to repeat them again. But let me get you into okay. So I want to show you, and tell me if you're showing if you're seeing this slide. Okay. Well, I'm going to share this with you. That's what happens when I do a share the screen. It gets into trouble, folks. Just to watch it out. Do you see my screen, folks?
Yeah, we can see it.
Okay, very good, very good. Let me. When the screen goes short, I lose the chat. I guess chat gets you know, sort of you know, it goes over, not good. It's there somewhere, but it's not obvious. But in any case, just stay with me, all right? Okay, folks, I'm showing this to you. Okay, let's talk about syllabus here. I'll give you sort of an introduction of why we are here, and then we're going to do this. Okay, I want to say something about myself. I have both academic experience as well as the industry experience. Okay, and I worked in industry in various domains, voicemail, you know, a storage system, healthcare, networking technologies, mobile, and then various applications on the banking system, for example, trading system, for example. So one of the things that I can mention about myself is that I mentioned mobile experience that I've had. So you know about Samsung, you know about Android, and you know, Android is an operating system. Android is a device. And Android has got thousands of applications, but they are all tied to Google. Okay. So we had Samsung, and you know all the products of Samsung, smartphones, laptops, and they were interested to get Android operating system on their devices. Once again, everything about Android is tied to Google. Google owns them. And the operating system part of the Android is open source. So, and then Samsung was interested in Android applications and didn't want to have any conflict with Google. So they gave us the funding to basically get Android OS operating system working on various devices of Samsung. Because Android operating system was open source. Okay? So imagine you have an Android device, Android operating system, it's got thousands of applications, Android applications. Okay? Someone lost connection. You hear me, folks?
Yes, we can.
Yes, good. Okay, so it's like when you're talking about the device, it's like if you have a Ford car and then you have a Toyota car. You have an engine that is for Toyota, Android, and then Samsung, a Ford, wants to get basically the engine from the Toyota engine and put it into a Ford. That's what we did. I was the sixth engineer on that project. I was the sixth one, and there were 3 in the U.S. and 3 Europeans. And that's what we take on that project. And I worked on that project for 3 years. So that's something about me. And beyond that, I'm educated I have a PhD in software engineering, and then so that's my story here. So I've identified a set of where's the disk? Okay, I have identified them. So we are talking about parallelism, concurrency, and multi-threading. So I've identified a set of textbook. You see, we have one book, parallelism compared with the concurrency. So there are areas within each book that I'm going to cover in here, but it's going to take a while to get. Well, I shouldn't say that. It's all everything. There are specific things that I will get to talk to you about them when we get to them. But a lot of other stuff is really, I'm going to look mostly in the Java concurrency. We're going to look at to see, different libraries, and also I look at the Android operating system for you. Because Android as an operating system uses both Java libraries, and it's got its own extended Java libraries. Those are specific APIs for Android. So, but you cannot get the entire speed out of Java. So what Android does, Android will, uses the application interface. We're talking about the operating system here. There is an application layer, and there is an application interface, and then which has all these layers of the operating system, and then connects to the machine, which is your hardware. Everything gets executed at your machine, So how are we going to get from user application to application interface to layers of operating system, and then connect to the hardware layer? And that connection space between the operating system and the machine hardware is called kernel space. So you have a user space, and then the connection becomes a kernel space. So if you're thinking of the operating system, it's got the application layer, You have all these other layers that manages the scheduling, memory management, and many other things. And then you have the the kernel layer, or kernel space. And that's where you connect from the operating system connects to the machine. Okay? So it's not the topic of, the kernel is not the topic of this class. But that's just general information, you should know that. So what do we do in the Java world? We're going to go inside JVM. So this is what I was talking about. So Android as an operating system uses Java, the interface, the application interface, or user space, not user, application, user space, okay? And then crosses into C++ and C and assembly as you get close to the machine. It does that because you cannot get the entire speed out of Java. But it benefits from things that you can do from Java APIs at the beginning, and then have the C++ and C gives you more speed to do to execute the instructions. Okay, so that's what Android operating system is. So the part that is Java, okay, is basically uses JVM, Java Virtual Machine. Okay, its basic JVM is just to manage that. It takes the instruction and push it onto the stack. Each instruction is a frame and push that onto the stack. That's just basically what JVM does. And we're going to look into that, specifically how that works. JVM also supports the garbage collector. We're going to look into see how garbage collector works. We already use garbage collector is memory manager, right? Basically, you write application, you probably wrote Java applications, but not worry about how garbage collector works. But garbage collector basically works at the behind the scenes. You don't have any memory management in Java. You just you have you basically you instantiate objects and use them. But it is the task of the garbage collector to basically look at manage memory. When you're dealing with code C++ and C++ is object-oriented programming like Java. So if you compare Java with C++, it is basically design-wise is the same. You have to think of objects, then you basically build relationships, associations, and with objects, and basically provide the code. But C is a procedural language. Is different design thing. When you're thinking of design with C, you have to take one problem and divide it into subproblems, divide it into subproblems. These are not divided means as a thread task. These are divided as a functions. Like you take a big task, a big function, and then you divide. This is what I want to do. I want to take function 1, function 2, function 3. And you build the code, you design it such a way that you take a big code, the goal, you break down into sub-functions. And then you break it down until you no longer can break it down. So it's called the water flow approach. Procedural is a water flow approach. But in object orientation, C++ and Java, you have to think of objects, and then you put the relationships together, and then move, and then build your software. So what is common with C and C++ is the syntax. Okay. I may introduce you nothing soon if I get time at all. I will try to get do some introduction to C++, not C specifically, but with Java. At some point maybe I want to show you, with the performance of under Java versus C++. I may teach you a few things on C++, but I don't know at this point. But what I want to say now is that what is the difference between C and C++? The design is different. You think design differently, right? One is water flow, one is object-oriented. What happens is this one syntax. There is the memory management between C++. They use a subset of memory management. What happens? Someone is talking to me. Everybody hears me? One person say yes. Hello, everyone?
Yes, we can hear you.
Good, very good, very good. Okay, great. So these are just general introduction. Is that C++, the design is different. When you're thinking of design of software, it's different. But what is common is this piece of memory management. And memory management means that you have to when you allocate memory to an object, you have to make sure that you allocate and use it. When you finish using that object, you have to dereference it. You have to delete it. You have to remove it. It's not like Java, like a garbage collector, is going to handle it for you. You have to, if you're doing allocation of memory, and you have to make sure that once you're done with the object, you have to delete it. Otherwise, you're going to have a memory leak. Actually, if this is running for large loops and you leaking every time, that's going to add up, and then all of a sudden you see your system is frozen. It's not doing anything. Okay? So that's one thing. So in Java, the garbage collector manages that. And I'm going to look into how garbage collector works. Getting back to something about C++, I want to say that, the memory management, and what that is what you have this concept is called pointers. What is a pointer? A pointer is just a variable. Say you say int x is equal to 4. So the operating system is going to return to you 4 bytes and call it x, and then it puts the value. It gives you 4 bytes, a 4 bytes address, and then it says you put 4, assign 4 into x. So put 4 into int x. So you remember, every storage has two things: an address and the value that goes inside that address. So now you say int x is equal to 4. Operating system is going to return 4 bytes address, and then you put value 4 into that address. Okay? Now, we're talking about the major thing about memory management is pointers. So in int x is equal to 4, so you have a variable x of type int, and then you put value 4 into that variable x. Now, with pointers are also variables. Okay? But so you say int pointer y. Now, remember, I said pointer y. Well, not to worry about it, how we do it, but just hear me for now. Or just as an introduction, actually. So, just int pointer y. Okay? So now you have a variable y, but is a pointer y. What that means, what that means is that the operating system is going to return to you a 4 byte address because you said int pointer. Why is it people going and coming in? People going and coming in. Could you stay on, please? Okay, so not to confuse you a lot, is not important. just as a general information. So we have int x is equal to 4, and then int pointer y equal. So we have a variable x, regular integer, and then we have another integer which is a pointer y. The difference between these two is that every variable, you have every storage, it's got an address. So when you say int pointer y, operating system is going to return to you 4 bytes address because int is 4 bytes. If you say chir, that's 1 byte. So in this case, we have int. If it's a double, it's a 4 byte. That means you have 232 bits. Now this goes back to, remember, there are connections between the architecture of the machine and what you do in operating system and in your application. If the architecture of your machine is 32-bit, that's what the CPU is going to execute. Each instruction is going to load. But if you have something called long X, it's going to be 8 bytes. 8 bytes is 64 bits. It's not 32-bit. Your architecture of the machine is 32-bit. That's 4 bytes. But the code you did in your program, you said int long X, and that's 8 bytes. 8 bytes is 64 bits. So how do you connect the 8 bytes with the 32? 8 bytes is 64. Your machine is 32-bit. So that means that CPU has to do 2 cycles to manage your long variable that you defined. I'm not going to go there, but I just want you to know that there is a connection. You have memory, which is addresses, but so you write the operating system or memory based on the architecture. When you do a physical memory, it's going to be based on the architecture. Architecture is 32-bit. Memory addresses are going to be 32-bit. But you have a local variable called long X. That's 8 bytes. So 8 bytes is 64. That means you have to use 2 memory addresses, 32-bit each, to get a 64, right? Say yes. I don't want to. It's not I'm just mentioning as a general comment that what goes on. This is why it's important that you take the operating system class, because you're going to learn all of these things. Okay? And I don't want to spend a lot of time, but I want you to see that everything has to be work correctly. You have a 32-bit machine, but in your program you say long X. That means it's 64-bit. 64-bit is 8 bytes. That means the operating system CPU, 32-bit, 4 bytes, is going to have to do 2 cycles to manage a long. Because it's a 32-bit and then another 32-bit. Okay? So that's all I wanted to say. And then I want to say something that I was on to with C++. So you have variable int 4 bytes, x is equal to 4. Then you have int pointer y. What is that equal to? So when you say int pointer y, the operating system returns a 4 bytes address because you said int. But then what do you put into that address? Remember, a storage is an address and then the value that goes into that address. Okay? Now, so what do you do? What do you do? What are you going to put into that address? The difference is that the value that you assign to a pointer variable has to also be an address. An address has to be a valid address. So how is it? If you're thinking of the memory addresses, right? It starts from 0 to the power of 31 if you have a 32-bit machine. That's the range of addresses that you will have in your memory. So when we're talking about what you put into a pointer variable is an address. So that's the thing. You have whatever you put into a variable pointer. A pointer variable has to be an address. That means you have a y pointer that has an address, and then you look at the value of that address. It's also an address. That means go to the other address. That's what pointer does. It says, okay, it has its pointer variable, has its own address. You remember I told you operating system returns 4 bytes address. But then what you put into that has to be a valid address. Like for example, you cannot put 4 into pointer variable. Why? Because when execute, you're going to crash. Because there is no address port 4. But if you say int pointer y equal to the address of x, because x has an address, is a valid address, operating system allocated that because it's automatic, it gives you that. Okay? If it's not pointer. So you assign an address, is an add sign, x. That's okay, because now you're saying address x is referencing another address, and then it goes to that address which is also valid, and it's going to work out. Now, if you don't have a valid address to assign to y pointer, you have to do allocation. You have to do a force alloc call or malloc call to, or new. In C++ is new and malloc. C++ supports both malloc, alloc, and new, but C doesn't support new. Okay, it's not object oriented. But in any case, just a taste of the differences between C, C++, and C++ and Java. So there's this garbage collector that you're gonna look into. I'm gonna teach you how the internals of the garbage collector is gonna work. Okay, so that's the idea. We don't worry about memory management in Java. And the way garbage collector works is that every so often, I told you it's in the background, it's a process in the background. What happens every so often kicks in, and it's going to look at all the objects that are visible. And then it tries to detect which object, there is object that has no reference. Try to detect if there is no object that has any reference. That means nobody is interested. So you created object A, and then you moved on, created B, C, D, and you started your program. And then some point you created B, and then you assigned it to A. And then so at some point A no longer was used. There are different ways. I'll talk to you about that, how it becomes invisible, that you used it, but then you deassigned it. So that's what garbage collector is going to detect. It's going to look at all the objects that are visible and detect which one is not having any interest. Interest means no other object that has a reference to A. So the A becomes a target to get deallocated to our memory. But there are stages that it goes into, and I'll talk to you about that when we get to it. But that's how it works. Look at the list, look at to see who is referencing it. If it's no reference, there's going to be it's going to be detected to be removed. And I'll talk to you about that. That's how garbage collector works. Okay, so let's get back to this. So I have the set of books. The grading system is going to be basically 50% homework and quizzes, 25% assignments, and 25% quizzes. What I have every week a quiz, but the quiz is a subset of the homework. The idea here is for me to get you work, but I don't have surprises. You have the assignment, you start working on it, then you have a quiz on it, and then a day or two later, you're going to have the assignment to provide the assignment. But quizzes always are simpler than homework. If you exact homework, I normally don't ask a lot of coding during the quizzes. I want to see you made progress. I want to see you working, and that working means to me that you're learning. And then the other big target about my approach is that I'm hoping that this is really important, like another class is important as algorithms class. These are really important. Nobody sees the internals of thread. Nobody knows how multiprocessing works, how multi-threading works. Nobody knows internals. I've been in the industry, a lot of people that struggle with managing threads because you can't see inside the threads. Threads are managed by the operating system. So this class is going to help you to basically do that. And then if you write good programmer with multi-threading, you can write, sophisticated programs. And that helps you to get a job. Or you advance your studies. So that's the idea here. Once again, 50% assignment is given, quiz next week, but based on the assignment, a subset of assignment. Okay? So if you do the assignment, you can collaborate, you can work together, but don't copy paste. It's not helping you. It's not going to help you. You're not going to learn. So when you get the job at the company, you go through a series of interviews, and then at some point they get you invited. Nowadays they do it from home, but in any case, they get you to when you get to the company, they will take you next to a blackboard, and they ask you a question. At that moment, there is nothing to help you except your training and your experiences writing. Okay? That's one of the reasons I want you to write. Every time, every quiz, to write. Write on the paper. So that gives you enough practice, and you're going to be sharp when the time comes, when they ask you questions. So the other thing about writing it with paper is that I don't know how it works for you. For me, copy pasting, going factoring, you don't really learn. Okay? You learn, but you don't learn in really specifics. You miss the specifics usually. But with handwriting, you're slower, right? You're slower. But that's not the exact reason I'm doing this. I'm doing this for you to be successful in your interviews. That's the most important one. That's why I want you to get enough practice writing and hopefully help you to get a job, a good job. I have people in my approach, they're getting really Amazon, Google, Dell. I've had Dell, Microsoft. So the other thing about this is that we are using too much computer to do things. Computers are really good. I've been using it for a long time, but it's good to take a break sometimes, I think, in general, from all machinery, but those are exertional factors. But the main thing is for you to get enough practice so you can be successful in your interviews. So that's why I'm asking you to write on the papers. Once again, you can collaborate with each other, you can work a brainstorm, and try to learn. My goal here is for you to learn, And if you do learn, you do the work, the grade is going to be okay, The grade is like without saying, because you're learning, you're doing the work, the grade comes with it, So not to worry too much about grade. Just try to learn and learn and learn, I guess, and everything else is just falls through. Okay, so I have several things that I'm going to talk to you about JVM. So we're going to talk about a number of things about thread. and I'm going to introduce you towards the late with some distributed system architecture. In this case, I'm going to use, it's called ACA actor model. Okay, so everything is distributed, right? You have, servers are sitting on the network, and then software has to manage this network of servers, and it's distributed. Okay, so what happens? And the reason I use the ACA actor model, because multi-threading within your system, multi-thread. You're writing a code application is multi-threading. You don't see inside of your thread. Although at some point later towards the end, I'm going to teach you some test strategies, about testing threads. So I teach you that. But normally you cannot see. If you have an object, you can print the objects and see what's going on. But if this object is a thread, you cannot see inside. So your threads, you have lock, unlock, and you have blocking, unblocking. Remember, I told you, you're going to hear this word again and again because it's so important. Okay? So what happens is that threads are coming in, they need resource, concurrency. They need to, get blocked, lock, and then you coming becomes blocked. I become blocked. And then I finish, I get unlock, and then you get unblocked, and you access the lock. So this is how concurrency works. But what I'm saying is that if thread environment is that side, there is too many contention because everybody's fighting for resource for the apple pie. Whoever is coming in, gets a. And one thing about threads, if you start in 10 threads and you print them, you receive 1 and then you see 20. Thread 20. Then you see thread 5. Then you see thread 2. Even there is no logical order. It doesn't mean it's incorrect. You have to make sure the code is correct, that the behavior of the thread is correct. You see? But the order is managed by the execution is managed by the operating system. And operating system sometimes it's only scheduling, memory management, all sort of stuff that is not going to be able, it's going to execute the thread when it thinks it can do it. And that thread could be 11. So the order of threads, you've probably seen it in your object-oriented programming, that when you print threads, the orders are not. But doesn't mean it's incorrect. It just means that you have no control over execution. It is the operating system. So we have this multi-threading. There are contentions. We have to worry about this lock, unlock, locks, unblocked. Okay? And what happens sometimes happens, there is deadlock. A deadlock can happen when you're accessing one resource, apple pie. So, and then I have a lock on cranberry apple pie. Okay? And then while I'm working in the cranberry, I'm going to need apple pie. So I'm going to make a reference. I am locked on cranberry pie. But while I'm working in cranberry, I would need the resource apple pie. Okay? And then you're locked into apple pie while you're working. This is a thread task. This is your program. I'm just making up. I'm trying to describe the scenarios that possible deadlock happens. What is the deadlock? So you have access. So you lock on the apple pie. Within apple pie, requesting access to cranberry pie. I am locked into cranberry pie, and I'm making a request to access the apple pie. So we both, you're locked on the first one, referencing want the second one. I am locked on the second one, asking for the first one. So in this situation, there is a deadlock. It means that deadlock could be if this request. It doesn't mean that this situation is bad. No, the deadlock happens if these requests happen exactly the same time. It means that while I lock on Cranberry, requesting to access Apple Pie, and while you are in Apple Pie requesting for Cranberry Pie, we're making the request exactly the same time. If that happens, there is a deadlock, because I'm requesting the both two requests at the same time, but we both have locks on each one of those pies. You're making a request from Apple Pie to Cranberry Pie, but I have to release that before you can access it. And then while I am in the Cranberry Pie making a request to Apple Pie, you have to release Apple Pie before I can access. You see? So if there are locks on two resources, and then within those resources, the threads are referencing the other threads at the same time, a deadlock happens. And what deadlock causes is that nothing can happen. It could be sitting there, it could be sitting and basically starve. Or you're waiting on me and I'm waiting on you. Nobody makes the progress. Okay, so there are various scenarios can happen in multi-threaded environment. In multi-threaded environment, in various scenarios, you don't know how many threads you have. What do they do? You don't see the inside the threads. They do different things. There are contentions between fighting for resources. You have all of these things going on, okay? And if the thread size increases, like depending what the application is, and you're even affects the one scenario. I told you there. Consider right now, folks. You just hear me, okay? Not to worry about to know all these details, okay? You're going to learn all of that. I'm just trying to give you introduction to what we are here, okay? But one scenario, so many things going on in managing threads. Well, one of the things could happen is that you have an application that has a CPU, maybe not good CPU speed or not enough, even with a good speed, but your request for services is larger than. It's not a steady state. You're requesting more than what CPU can do. If you're pushing that, what that does, imagine a scenario that you have multi-threading, threads are locked on resources, and then it hits the CPU cannot handle all of this. And what it's going to do is you're going to see that the operating system is managing all of this memory management and CPU. So what happens is that CPU cannot handle it, but then operating system is making a request from one thread, while that thread is locked into Apple Pie, and then making another request from another thread, and then that thread, the CPU can fault because it can input request for request and service for request is not handled. So what happens is that causes the operating system to do preemption. What preemption does is that you are in the Apple Pie. You're in the middle of your work of cutting a piece of apple pie, and then you eat it, right? But then a preemption happens. Because operating system, there was not enough resources at CPU, but then there was some other high priority thread happens, and the operating system is asking for the CPU cannot handle it. So what happens? It has to provide a release to the CPU. What is it doing? It's going to do a preemption on CPU. I'm sorry, on the thread that is in access apple pie, because that puts a suspension on the thread that is locked in apple pie. The suspension means that it's going to lose control, and then now there is a relief, and to give the lock to a high priority thread, and that high priority thread can be handled because there is a relief to the CPU. You see, everything is interconnected. But what happens is, this is one scenario. Preemption happens, and then you get the lock. You're going to go do whatever you want to do with the lock on the apple pie, and then when you finish your release, and then operating system has to manage to see whether it gives you it gives me, which I had hold the lock before, to continue with my work on this. So I hope that I don't want to say too much, and I want to give you sort of big picture how everything is really working. I went through all of this. Contention, not enough resources, to say that if you take this idea with the multi-threading, and you do multi-threading on one system, and you have a thread dying, a thread could die because you keep waiting to get access to a lock. It never happens, and over time dies. And a thread dying could cause a reciprocal effect to other threads. It's not that just like a thread dies, but it could be affecting other threads, and that could be this situation. What was the intention of that thread? Maybe that thread was going to do. Remember, a thread is a task. Maybe the output of that task was something that was input to another task, which is another thread. If you have put a thread that creates the output in a situation that is keep waiting for getting access to the lock, keep waiting, it never happens. That means it's never going to generate the output that is an interest to another thread. So a starvation on the thread A, which provides the output to thread B, a starvation causes thread A to die. But the fact that thread A was not successful to generate the output will cause also thread B to die, because it doesn't have an output. You know what I mean? It's all logical programming here involved here. But I'm just going to give you scenarios of what's going on within managing threads within one system. Now, we are talking about distributed system. If you have objects that you call, and then you have to do this locking, unlocking on different servers on the network, and what are the chances of success to manage this lock, unlock, block, unblock, all those things. So this is why I went through all of this to tell you why I use the actor model. I'm going to introduce you to a distributed system architecture using ACA actor model. And what this is a message queue. With a message queue, you basically direct a request to a specific actor, it's called, on the distributed system. So you have a distributed system based on actor model. So actor model is basically is a messaging passing this message to this actor. That actor maybe provide service to that message, or it says, it's handled by another actor. It's going to pass it back. So it's a message queue. You're creating an object, and then you say, actor B, I'm going to must pass it to actor B. So there is no contention here. There is no thread managing here. You know exactly A and then you create an actor and you send it to B. So it's me only. It's not, it's identified as me. Nobody else is going to be worried about that. It may take, it's going to be queued up until you see it, but that's it. There is nobody's fighting for that except you. So that's why distributed technology, IBM actually uses this. I'm going to give you an introduction on this, and maybe I build something on it. And then sort of other things, and maybe give you a comparison with Java multi-threading versus C++ multi-threading. I give you that because they both are object-oriented programming. When you think of designing a solution to a problem, you may, your Java and C++, you think the same. It is only implementation difference. One uses references. Java is passed by value. C++ is passed by reference. I'll talk to you about that later. But it's important. I'm going to first, most of the things I cover is basically covered in Java or. But there are sections at the end that I introduce you to. Okay, so that's the thing here. I have a list of topics that will be covered in this class, and then I will take you there. And there's like interesting thing. You'll see item 450 is atomic operations. If I start talking, I have to talk at least 50 of the 30 minutes on it. But I talk to you about it. All you know is this. Operations, atomic operations. That means, remember, multi-threading is the threads are running simultaneously. So with the atomic operation, threads are going to fight contention for resources. With the atomic operations, is that a thread can basically run its own operation without contention, because it's atomic. And I'll talk to you about that when we get to it. Regular threads are fighting, generating contentions for resources. Atomic threads with atomic operations don't need to worry about that. They can execute when they have to. And that's a big difference. You don't need to, and it's a tricky business, okay? And I talk to you in this book. You see this book here, Concurrency in Practice. There's some details here are very good, okay? But I talk to you about that, how that actually works. How can a thread not fighting for resources, So it's going to go hard and work as on the side of the thread that requires does the contention. Threads with atomic operations don't need, so they work simultaneously. But one doesn't not need contention and one needs. I'm sorry, one needs resources, and one needs resources but doesn't fight for it. The other one needs a resource and fights for it, which causes contention. So I talked to you about all that. So things that I covered here that I want to get all types of experiences with threads, multi-threading. Everything I cover in here is all about threads. You will see so many things. And okay, so that's the story. Okay. Let me ask whether everybody is good, folks. Everybody is good with me?
Yes.
Very good. Don't whatever I said here, you're gonna every one of these ideas I talked to you about, you're gonna get actual practice. So I wanted you to hear why we are here. These are the kinds of topics we're gonna deal with in here. So not to worry about if you miss things. You're gonna get it. Okay. So with that, let's okay. It is 7:53. Do you want to take like a 10 minutes break? because we have to run to 9:30. Everybody? Okay. So folks, take 10 minutes breaks, and I see you at 8:05. Okay, great. Hello, everyone. Okay, so let's get back. So what's going on? The first thing we need to look at, what is the first object in Java? The first object in Java is object class. So, you know, if you don't have, it's automatically inherited in everything that you do. You don't have to say object, extends object. Object is the first object in Java. Is the object class. So, and this object is it provides a set of methods, APIs. Like you know, it's got lock objects. So they use less lock objects to solve deadlock problem, as I talked to you about that, but not to worry about it yet. So basically, when you do these lock methods that you use, there are different ways, there are different objects inherited from objects. Either you can override it or just use it. So the first class is object class, and so that's so we're gonna so we've got we're gonna see how do you do. So when you create a thread, let me start with this thing here. Look at, so what is a thread? We're going to need this Java object, which is class object, but inherited. You don't have object class does not have any inheritance. That's the start. And any subclass is going to automatically inherit the object class. Okay, I'm talking about class, not instance of the class object. Okay, advantages. What is a thread? Video game process, networking, interaction, video. So what is a thread? You have an application that one does the video game, it does another thread networking, another interactions, another video. Each one of these is a subtask. Okay, so we got, it's a thread. Each one of these is a thread that does the task of video interactions. That's the task. One thread is doing networking. One thread does a video game. You see the video game process. That's the circle, the entire thing. You took the big picture, big task, video game process, and you broke it down into subtasks. And you generate threads for each one. Each one of those subtasks is video interaction networking, 3 threads. So you took the circle and you divided by, you broke it down into subtasks. And each one of the threads are doing different behaviors described. Okay, so that's, and then advantages, easy to program, one thread for a task. Can provide better performance, right? Because you're running things simultaneously. And I talked to you about parallelism versus concurrency. But concurrency is still better than single-threaded. Concurrency means that if you need the resource, you have to manage the resource. the thread cannot make progress, but once you make a progress, it can make a progress. So can provide better performance. Thread can only run when needed. No polling to decide what to do. No polling means that, oh, you're asking what to do. No, you're not asking what to do. You know what to do. That polling, asking what to do, it takes some time, right? You have too many threads are polling. So threads don't, you don't have to ask what to do. You already, you are a task. That means you do whatever you do. What are your tasks to do? Multiple threads can share resources. I'll talk to you about shared resources. We'll get more specific to this. But, so one of the, for example, the context of resources, for example, if you're loading a program, loading another program, they both are they are asking to be loaded. The first thing is that you need to allocate memory for them. How about if you don't have memory enough? You get blocked. The loading becomes blocked. They both may get blocked, or one of them get blocked, or none of them get blocked, depending what the resource is available. If you want to get connections, not, you have limited sources and connection resource. You cannot just connect everyone. Every connection takes the resource away. You have so many different limited number of file descriptors. You open this one file descriptor 1, 2, 3. So that takes the file descriptor limit that you have on the system. So if it gets to the limit, the last one that wants to open, it cannot open because you don't have a resource, file descriptor resource. So there are all kinds of things about resources. There are resources that you create in your program, like a pie, like a hash map, or array list, or a hash set, because you want to a queue, a stack. So that's what but the threads are requiring shared resources. You create a shared segment into memory that holds the data that is general, that all threads can use. And then you can basically, but not everybody can access the resource. So now then there is this parallelism and there is this concurrency. Parallelism, you have CPU, it runs from start to end. Concurrency, you have to fight for resource. Okay? And that could, within the context of multi-threading, concurrency could affect the performance, but not comparable to if it's single-threaded application. Do this one, and then then get the next one. Go 1, 2, 3, 4, 5, and then the next one. Okay? Utilize multiprocessors if available. Okay, so what is the context of the multiple processors? These are CPUs. I have to tell you that there is a process and there is processor. When we say processor in the context of CPUs, how many CPUs? CPU 1, one processor, CPU 2, second processor. But when you load your program 1, program 2, those programs get loaded into memory and then becomes a process. And every process has a process ID. You have 20 programs, you have 20 process IDs. Becomes a process. So a process is the software loaded into memory. and processor is the CPU. So one is software and one is hardware. So we're going to learn about all this, okay? You know it already, but we're going to learn more specific about things. Okay, so how to create the threads? You need this. It is a thread class. You can extend. This is a concrete class in Java, and it's got a run method. And then you create an instance of the thread, and you're telling it what task to perform. So you get instantiated the thread, and then you pass a task to it, because you say, you thread, work on task 1. Then you create a second second thread, and you give a task. So every thread has a same task. Different task. Okay. So they show you examples of that. Okay, creating threads example 1. You know this. You have class output extends thread. Now private string to say. So you know all this. This has variable string and then the constructor, and then you have the run method. The run method, what is it doing? You're going to a while loop, for loop, and then every time you say hello, and then you have to wait 1 second. That's 1,000 milliseconds. And then you have this try and catch clause, where you try, and if it fails, you have, if something goes wrong with the for loop, a catch clause is going to happen with the interrupted exceptions. And then you see the system output, you're just printing the exception. What kind of exception will be the true? So you should have covered this in your object-oriented class with Java. Is that the exceptions, right? There is a hierarchy exceptions. So I may get, if there is an example, that I will talk to you about it. But interrupted exception could inherit runtime exception. So this is a sub-exception of the parent's exception. That parent could be super parent exception. So there is a hierarchy in the order of exceptions that needs to be considered here. So the way you want to do exceptions, it has to be logical. You have all these exception types. There are hierarchy within exceptions. So when you're deciding to throw an exception, you want to know why you're doing it. What is the reason? And then you look up the exception type, and then you catch clause on the exception. So that's that. And then example, okay, so what do we have? We have a main, we have 2 objects, thr1, 2, and 2 of type class, and then you new, that you create an instance of output. Remember, output was this class here, which is a thread, because output extends the thread. So when you do in here, you create thr1 and thread 2, thread 1, thread 2. They both are a thread. Okay? Because output extends thread. So thread 1 is a thread. Thread 2 is a thread. And then what do you do new? You give it a task. The first one you give it, say hello, and the second one you passing, you say there. And then you start thr1 start, thr2 start. Main thread. Okay, so one thing is, in Java, when if you don't have, say, output thread 1, thread 2, you know about this. You create an instance with the task, and then you start the thread. Okay, start method on each one of these threads. Assume that you didn't have these 4 lines of code. All you said, system print out hello. So what happens is that you're always going to have at least one thread. And that is main thread. Okay? We're going to dig into this thing further. But for now, how many threads do you have? If I ask you how many threads do you have in this example, you will have, you say 3 threads, because you have 2 threads, 1, 2, and then there is also a main thread. Everything in JVM runs as a thread. Java Virtual Machine is a thread. So main without any. Right now you have a main thread, and then you have 2 other threads you generated, you're creating, thread 1 and thread 2. So you have a total of 3 threads. And then each one of those has I'll show you later, it's got a thread stack. Everything about JVM is thread. And this is how JVM manages your program, because it manages a thread stack for every thread. And main is one thread. Okay? So you see, main thread is just another thread, happens to start first. Main thread can end with before the others do. Any thread can spawn more threads. Okay, so creating thread method 2. So we are implementing, now we're going to use a runnable interface. So you probably know this. In Java, you can extend only one concrete class. So when you're designing your program, you have to be careful how you use that one. You know, in Java, is only single. You can do single inheritance. 2 concrete classes. Thread object is a concrete class. But to get around multiple inheritance, Java provided interfaces. You can extend one class and then implement multiple interfaces. Okay? So the thing is that, but C++ is also object-oriented, but C++ allows you to do multiple inheritance of concrete classes. Java, single-threaded of concrete class, single inheritance, but allows you to get around multiple inheritance through interfaces. But remember, multiple interfaces have no implementation. It's just what is it that is the abstract holds abstract method. Oh, this is going to happen. It's abstract. It's no implementation. But when you do multiple inheritance of concrete classes like Java, there are issues can have. I'm sorry, like C++. Then you have to manage some of the issues that come. It's like the diamond problem. What is the diamond problem in C++? It is so what happens in C++? Okay, many things. I don't want to spend too much time at this point, but I get to it later. But I'm on the topic that I need to say it. Is that with the multiple inheritance of concrete objects, what happens is that it causes diamond problem. Diamond problem is this: you have one inheritance, second inheritance, third inheritance. You can do multiple inheritance of objects. Not okay. So if you look at it, when we say object, classes, right? Classes. And then classes becomes objects. So you multiple inheritance. So you have a method. It's done exactly the same signature. You don't call it method in C++. You call it function. So you have a function with a signature. And then in another class, superclass, you have a function, the same function. Not the same function, but is the same signature. What is the signature? A method name, the arguments that pass into the function. I keep forgetting. Method is in Java, which is a function, okay? But they call functions in C++. So the signature of the function or method is the same in two inheritance. They may be implemented differently, but the signature is the same. So you have class 1, class 2, and then you say my class inherits in C++. And my class inherits class 1 and class 2. But class 1 has a method signature which is exactly the same. The name is the same, the data passed into the method is exactly the same, and the return type is the same. That's what signature of the method is. Not how the implementation details. No, just the signature. So what happens with C++? You have to compile this. And when you compile, you don't know, you probably meant you want to really call your program to use the method in class 1. But when you're doing a compilation, you don't know in C++, you don't know what order, because what happens is that you compile and link and then you have an object code. Remember, one makes a big difference also in Java is you compile to bytecode. In C++, you compile to machine code. Okay? And then you use Java interpreter or but whether you use interpreter or just the complete compile, it still compiles to bytecode. Let me give an example. In Java, you have something called, you do Java C, compile it. Java C generates the bytecode. Okay? Then so it generates the bytecode. I keep thinking the interpreter takes each line of code and compiles it into bytecode and executes. There is also a tool called just-in-time compiler, which takes the entire Java code and compiles it to machine code. Okay? So either way, whether you use interpreter or just-in-time compiler, Java compiles to bytecode, and then you have to use Java to execute this, to take it to machine code and then execute. So it takes the bytecode. There are two steps in Java. That's why Java is slow when you have to build large applications like compilers, or I'm sorry, the operating system and file system cannot do, because it has to take the bytecode and convert it to machine code and execute. Okay, so creating thread example. Okay, and something about diamond problem with C++. So you have two methods, exactly the same thing, the same signature, but different implementation. But when you do compile and link, you may link to a wrong object because you cannot control the order. Well, you can control it if you forget to specify the order, which is, if it's a large application, you have to provide in Linux called makefile, that you say exactly what the order of things should happen. But if you don't do that, you don't know when it's doing the linking, it may link to a different object that you intended. So the result would be wrong. And it's from the time that this happens until you find the problem, you're talking a lot of maintenance problem, because you have to debug, you have to identify the problem, then its solution, and so on. So that's what it is. Why am I getting a wrong result? Because during the link, you link to a wrong object. It was the same name, but the linker picked up this one versus the other one, and then okay. So that's what the dynamic problem is that C++ compiles to machine code, and dynamic problem happens with the same signature, functions with the same name. Okay, so the other thing is this about Java versus C++. Java, that's why Android uses both Java and C++, because operating system needs a speed. And so you can't get it from Java alone. If you write the entire operating system in Java, it's probably going to be very slow. But Android uses a higher layers, is using Android, Java, and Android APIs, which is in Java, and then uses C++ and C. So what that means is that assume that you have an application with 1 million lines of code, where 400 lines of code, 300 lines of code is written in Java, 600 lines of code is in C++ and C. So what that means is that if you take you heard this, that Java, you compile once and run it everywhere. So if you take this code, 1 million lines of code, to another machine, you don't need to take 300 lines of Java code, because you already compiled it once. And what you move, you move the bytecode, and the bytecodes are in dot classes. When you do Java hello.java, you do Java C hello.java, it would generate hello.class. So you have a set of dot classes within each one, and those are bytecodes. Okay, those are not machine code. The hardware runs only machine, 0 and 1. So when you move this code, 300 lines of Java is not needed. Only have to move the bytecode, and bytecode is already there. Okay? The other piece, I said 300 or 400. We'll say 400. And then the 600 lines of code is in C++. Okay? Then Then you have 600 lines of code is in C++. That when you take it to another machine, you have to recompile the entire code because you compile C++ to machine code, and the architecture of the machine could be different. Even if it's even the same, you have to recompile. You never know what's going on. And as soon as taking 600, 700 lines of code, you recompile. That's a huge maintenance problem. It's not just compiling. Once you compile on the new machine, then you have to go and solve each problem that compilation problem occurs. You have to solve each one of those problems. That could be for 1 million lines of code. That to be released again on the new machine. That's quite a task. But on the 300 lines of code with Java, you don't need to do anything. You only move the bytecode, the class files into the new machine, and as long as you have Java runtime machine running, where every time you install Java, you always get Java runtime, JRT. As long as you have Java runtime machine, it's going to execute your Java code. So no problem there. But the 700, 600 lines of C++ has to be decompiled. You know, and that could be a huge task. Okay? So, but, you know, C++ is a popular language because of speed. It's doing it's doing speed, so much speed, versus compare. So people are still, still admire the performance of C++, C++, and then they put up with the maintenance with it. So that's the story. Simple area of explaining that. So this is what so Java, in order to get around single inheritance, you can do multiple interfaces, and it's safe. You don't have a duplicate. You don't have any diamond problem with the Java, because multiple inheritance, you have single inheritance but multiple inheritance through interfaces. Interfaces have no implementation. Of course, you have abstract methods that you provide, and if signatures are the same, it will be notified at the compile time. If you're using, so you get some indication that something, at the compile time. The diamond problem is that you compiled, you linked, but the link was linking to a wrong object. So it's working, but you are not going to realize until you run it, or who is going to run it, you or a company running the code. It is at that time, at runtime, it's going to notify. But things in Java, because it's single inheritance and then multiple inheritance through interfaces, things going to be catched at the compile time. Okay? One thing about the interfaces. First of all, Java only provides interfaces. So you create interface 1 and then interface 2. What you do, you say, so this is what I was getting at. Because it's a single inheritance of classes or objects, okay, then if it's a single inheritance of classes, then Because it's again, when you're using that extended class, you have to be careful how you use it, because once you use it, you lost that opportunity. For example, if you right now you needed to create thread and you say extend thread, the thread object is a concrete class. And then later on, and then you say, and later on you created another class called my class. And that's concrete class and has some services in there, methods that is useful. Because you already have extended one class, extend thread, you're going to lose this opportunity you have to go and change this. You don't know at what stage you are in. You were wishing that, oh, I wish I had created my thread as a vulnerable so I don't lose the extension. So I could extend my class instead of thread. You see, those are design decisions that you have to know about the language and limitations of language, and that helps you to decide what to do at the design. Because if you do the wrong decisions, it could be too late. Then you have to work out different solution, different way to solution, which could not be easy. For example, if you had risked my class, maybe you were better off. But this is the thing. So that's you can create thread through runnable interface. This runnable interface has only one run method. You have to provide the implementation for this run method because it's interface. Okay. So this is another example, creating threads using runnable. So you understand this, right? You have the interface, you have run method, and the run method is the same implementation as you had for this. So you have, so this is in example 2 using runnable, the same idea here, but let's see. So you have, your output is implement runnable. You see the class output. The main class is going to be output, which is, and then you have, now you do use thread by composition. Remember, there is inheritance, also composition. So you create the object output, and which you want it to be a thread. You pass the task. Now the task is object out1, out2, and then now you pass the task to be thread, the real thread. Remember, here is the implements runnable. Implements means that you have to provide, but then you have to create instance of it, of the thread. A thread, the input to the thread is the object out1, out2. It's not a thread yet, but identifies out1 as a task hello, out2 task there, and then you include thread as a composition, and then you pass the reference to out1, out2 to 2 threads, and then you start the threads. So going back to this was the situation when you extend thread, the run method, and then the method in this case extends thread. So you see, output is already thread. Okay, so you just is passing the task hello to the thread because it's already thread. It extends thread. Output is a thread. But in this case, when you do runnable implement, is going to be a thread. It's not a thread yet. It's going to be a thread. You see the difference? Multiple inheritance interfaces, that's why they say in Java, multiple inheritance through interface only gives you partial inheritance, not full inheritance. Is the exact this reason. When you did this one, you said output extends thread, and then you implemented the implementation for run method because thread has a run method. Well, you're overriding it probably here, okay? And then inside main, you just create the objects with the task. So thread 1, thread 2 is already a thread. The thread libraries provides this APIs. You know, start, stop, suspend, join, and set priority. You know, thread start, you know what that does. And then thread wait and notify. This is very important. Everything is important in this page, but some of them are obvious. So start and then stop. You can stop a thread. You actually can, you can do, for example, you have a thread 1, thread 2, you can do the start, and then right after to start, you do thread 1 dot stop. Okay? Or, so what are the other options? Is that the options is suspend and resume. It says deprecated. I don't know the case, but basically suspends this thread. Basically, it stops this thread until it gets resolved and to continue. As I was mentioning, if this thread has a lock in the resource, a suspension is going to cause to release the lock, and then the suspension happens because it was the preemption caused by the operating system. And then join, wait for a specific thread to finish. Okay, join, wait for a specific, what is this does, join? So, for example, if you look at this thing, and then right after the 2 starts, you say that thread 1 dot join, and then thread 2 dot join. Remember, the main program is also a thread. Okay? Depending what the threads are doing, you say, right after this start, you're going to say, you may need to say thread 1 dot join, and then thread 2. You make both of them or one of them, depends on what you want. But if you assume that you do thread dot join and then thread 2 dot join right after this start, what that causes is that it's saying that the main thread is not going to finish until thread 1 and thread 2 complete and return. So for example, you see that you have 3 threads because you have 2 threads and then you have a main thread. Those are 3 threads. So it may be that you need that to make sure that threads are completed before you exit. Okay? So, because if you don't do, for some reason, it depends on what you're doing with the threads. What are the tasks assigned to the threads? If you exit the main, that may cause exit the threads, the other threads. You don't want to do that. In that situation, you're going to use this thread.join, which says wait for a specific thread to finish. That means don't exit main thread until the other threads are finished. That's what join does. It does the wait for you. Okay? And then set priority is the way is that you can change the priority of the thread. The default is 5, normal priority. So you create a thread at some point, depending on what you want to do with this application. You may you may want to set the priority change. By default, threads are going to be set priority to 5, normal priority. And then highest priority thread runs if more than one. So this is, so threads are managed by the operating system. And then operating system does the scheduling based on the priority of the queue. If the thread has the highest priority, it forces the scheduler, the operating system, to schedule it sooner than later because it takes higher priority than other threads. So that's why. So highest priority thread run gets run first. I mean, who knows? You could have set the high priority 10 at the beginning, or you may have changed it in the middle, by doing this set priority. 0 is minimum priority, and then 10 is maximum priority. And 5 is normal priority. So I told you they say suspend was deprecated, but yield is the current thread gives up processor, so another equal priority can run. So you basically, the processor, remember in here we're talking about the processor, that's CPU. If CPU is executing this thread A, and thread A calls for yield, then that forces basically the processor is going to give up on processing the thread A and gives the processing time to another thread with the equal priority. So the other thing is the sleep. You have a sleep method within thread. Stop executing for a set of time. So we had one example in here. You sleep for thread. You see, a sleep is. What do you think a sleep is? When you look at this code, what do you think a sleep is? A sleep is a static method, right? Because you're directly executing from the thread, the name of the thread, not the instance of the thread. The object class thread. So if you know about static data, static method, they belong to the class. So you can directly call them. You don't need to create an instance of the thread and then call sleep. You can directly call it from the class. And in order to do directly call from class, that method or data type has to be static. So sleep method is a static method because it belongs to the class. So we're going, okay. So we learn this stuff here, and then the state of Java threads. So we can be new, runnable, blocked, new just created but not started. You know, is this situation? You line 4 and 5. You created the thread but has not started yet. It's only started when you do .start. So that's the scenario. Runnable, created, started, and able to run. The thread has finished or been stopped. Okay, this is the diagram. So you create the thread new, and then you start, becomes runnable. That means you can run it. And then what happens is that the thread could get blocked and then get notified. You know, remember, it gets blocked because the thread wants to access the resource, but that there's a lock on it. On that resource, another thread has a hold on it, has a lock on it. So you become blocked. And then when the other thread finishes, then you get notified. And that notify means you're going to get unblocked and then lock the resource and continue. So you run it, either you finish it, then you die. So that's the thing. So the blocked information, the blocked state is important because that means you have to wait. If it's already taken, if another thread is already executing the resource, has a lock on the resource, you get blocked. That means you have to wait. You wait until you get notified. And then notify means you get unblocked and then lock the resource, and then you do the work on the resource, and then you continue. So the notify happens when the object that is holding the lock, the thread that is holding the lock, is going to get release the lock, unlock, and then the notify happens. Is everybody with me so far? It's one-way communication. Is everything good, folks? Someone? Good. Someone. Thank you. Let's see. So the thing is this. Okay, so let's look at this example. So we are creating a job. Class job implements runnable, and then we want to have 4 jobs, 4 threads. And then you have process thread ID, and then you have the constructor. You pass the ID, then you set the thread ID as ID, and then you have then you can have you can have run. Okay, so your run method do something, and then you have the main program. So the main, what does the main does? Main goes a loop from 0 to jobs length, which is 4, and then creates each job is a thread. So jobs array. So an array of 4 elements. The first one is a thread with job. Remember, you have jobs, which is an array of threads, and then you have job class. So what do? You basically you have an array of 4 elements. Each element is a thread. Each array element is a thread. What is that thread? Is there? It is a job class. It's a job object. Okay. See, you remember, so you see the thread, you're passing the task. You say jobs I, that's an array of jobs. In the first element, 0, you create a thread, and you inside the argument for thread is new job. So you pass the job object to create the thread, and that becomes the first element of the array is a thread. Then you start the thread, then you walk it through 4 times, and that you're going to have an array of 4 threads, basically. And each thread is a job. But a job, there is a class job and there is an array of jobs. You have to be careful with that. And then what do? You do that, and then you try. What you do is that you walk through the length of 4, and then you do jobs I join. What does that do? It says, so remember, you're doing this in main. You see, public static void main. Main is a static method, but also is a thread. So it's a thread. In that loop, you're saying every one of those threads, jobs I, join. Don't exit until, okay, you're telling the main thread not to exit until every other jobs are completed. Remember, right now, you created 4 threads. You have an array of 4 threads, one each element. And then you have the main thread, which is, you have a total of 5 threads in this example. And you're saying with the join, you're saying, don't exit main thread until all 4 other 4 threads are completed. That's what join does. Okay? So, we look at this, a schedule. You have 4 jobs, and then say schedule ID, and then do something in the run. Because it's a runnable, you have to provide implementation or run and do something. And then we have this main. Okay, so what do we do? Inside main, you have the next variable, next thread, 0, set priority to maximum priority. Set priority, thread maximum priority. Okay, so you set the priority, and then you go through the loop to 4 times, and then you create in the thread, each element of the array is a thread, set priority, and start. Jobs, next thread, set priority. Okay, so this is so basically next thread ID is next thread ID is just available, and then you set the next thread to be basically modularized to get the next ID. You basically is doing next ID plus 1 mod jobs length, which is 4. And the mod is the remainder, right? So you get, so anything divided by 4 is going to be remainder. So 0 plus 1 mod 4 is 1. Then next time is 2, next time is 3, then next time is 4. When it becomes 4, the remainder is 0. And that's where the loop ends. Okay, the loop. So the modulation to extend the indexing of the array, each element of the array is a thread. Okay, so this is only showing,
Hello, Professor.
Yes.
Sorry to disturb, but we can only see the Oracle tutorial page. We can't see the page you are talking about.
Did you see the previous page that I was on?
Yeah.
You don't see this page?
We can only see the Oracle tutorial page.
Oh. Folks, then let me stop and start. Okay, stop. Thank you for saying that, because I don't know. I asked a question. Do you see it now?
Yeah.
Okay, but the thing is that did you see this one?
I don't think.
Are you seeing the states? Do you see this?
Yeah.
I am moving. So I'm hoping that you followed all these slides. I don't know. But
I don't think we followed.
But you just heard me. Okay. Let me continue with this to see where it takes us. The idea is that you have to walk through these slides, but I think maybe I reviewed again, but maybe it's also self-explanatory after you because we are trying to be harder and harder here, But this example, you see this example too. Basically, this example, you create a job, and then main, and then do this, and then you do this one is scheduled. Basically, creating 4 threads. What is an array? An array of jobs, but each element of the array is a thread. That's what you're trying to do. And what this example does, example 2 versus example 1, is that it changes the priority while it's running. Set priority, okay? And then, so you will see when you do this and you run this thing, you see the thread execution. I will have this as a homework, that you basically compile this and see. Remember, you have no control over when you run and you say, look at the thread. You have no control of which thread to run. The operating system does. But the idea for set priority is that when the default is 5, but you can run it 1, 2, 3, 4, and 5. And so when you compile this first example and then you do this, it's hard for you to tell what the order of execution is because you don't know, but it will be different, very different, because of the set priority. That's all I can say. I cannot say it should be the same or not, because you have no control. But because you're messing around with the set priority, it's going to be maximum, minimum, or thing. You will see the sequences would be vast different, not just different because you have no control over it. I hope you understand what I'm trying to say, because you have no control over execution. Okay. Java 8 concurrency runnable lambda function. So you know about lambda function. So we have in Java 8 we supports the lambda function. This is is a runnable, is a thread, is a task, and then basically that's the syntax. You say it's a thread current time get name. A task is a runnable because a task is a runnable, that means it's a thread, and then you're looking at the thread name and this. So thread name and then you print it. So this is basically using lambda function as a way of creating a thread. And look inside. You see right after the lambda function, you see task.run. Okay, so that starts the run method. And then you have thread. You create a thread with a task, and then thread start. And then you say done. So, and then you see hello main, hello thread 0, hello done. These are the results of the thread execution. Okay. So if you walk at this is creating threads using, so you have one case you have a runnable, you creating thread using runnable, so look at the result. So you have the lambda function runnable, and then you pass the task to a thread. Remember, a runnable is not a thread yet until you do assign it to a task. The task does run because you have to provide the run implementation, implementation for the run method. And thread is new thread, task, thread, start. So look at the result. Hello main. Okay. So you see that the run implementation. You see this is how the lambda runs. The string thread name is equal to thread current thread get name. So get name current thread. Which one is? The first one is the main thread, right? So it says hello main, because you have to do main first, the main thread. But it's doing it in lambda as a lambda function, and then you do run, and then you do okay. So then you create a thread, the task, and then you do a start. So now you have a thread. and then you have a print done. So the second hello, you created a thread with the thread 0. Well, what are you doing? Because the print says hello plus thread name. The print name is 0 because it's a thread that you created. Something be aware of. I'm just trying to introduce the lambda function, but you got three print statement. Done is obvious because it's the last statement. It comes up. Then hello thread 0. Okay. Hello thread 0. Hello thread 0 is okay. So I get to that. Hello main. You see, hello main is the hello and then plus thread name. That first name is the current thread get name. Which thread is it running first? Is the main thread. So that's why you have the print statement hello main, and then the second one hello thread 0. Okay. Hello thread 0. That comes from the second, a runnable is ready. It can be a thread. You provide the run method, and then you create a thread and pass the task to it. And this is what the start is going to run. So you run the main method, the main thread, and then you run the running thread, which is the second one. And the second one, when you do a thread get current thread get name, is thread.0. The thread.0 because it's the first one, but then thread, there is no explicitly to say the word thread, but that could be internally. The intention here to show that the first thread that you created within your program. So you see that the lambda function is just, you don't have these rules. It's not this rule, but it works. So you have a task is a runnable. You run it, you get a main, and then the thread, and then you're done. So I don't know how else I can explain except that you walk through this code, you can tie together. With the lambda function in general, it removes all the rules. It can, it's open-ended write. You write anywhere. There is no, for example, if you compare with this example,